Welcome into the final exam review. We are going to do several problems that will help you with the final exam. The final exam will be comprehensive. So let's get going with some examples. The first question is asking us to determine if the variable is qualitative or quantitative. And so remember, quantitative types of variables are variables that you can do numerical calculations with and the results make sense. Things like weight, temperature, height, amount of liquid in a 2 liter of cola. And qualitative variables typically deal with categories. And I think I told you guys that another word that you can use for qualitative is categorical, the root word for categorical being category. So categorical variables are things like colors, car type, Ford, Chevy, Toyota, smoking versus non-smoking, freshman, sophomore, junior and senior, so on and so forth. So let's think about this first example here, month of birth of survey respondents. So month of birth would be a category because the survey respondent would answer January, February, March, so on and so forth, and this is a category. And again, it doesn't make sense to say something like January minus February is equal to 10, just like it doesn't make sense to say blue minus green is equal to 11. So the solution here for question number 1 would be qualitative. Okay, the second question is asking something about the types of sampling techniques that we've looked at: simple random, stratified, cluster, convenience. So it says, from a list of several villages, a market researcher selects all adults in each of 10 randomly selected villages. So you want to think about the idea of this list of several villages. So maybe all the way down to N. And then what we're going to do is we are going to take all adults in each of 10 randomly selected villages. So we're going to select maybe this village and maybe village number 4 and village number 7, village number 11, all the way down, and we might select village number N. And what we're going to do is we're going to take all from each of the 10 randomly selected villages. And so this points us to cluster sampling. Cluster. Okay, next question. This question I'm going to ask you to find the mean, median, and mode, as well as standard deviation of a set of raw data. So this is raw data. So the first thing that you want to do is, of course, just list out all of the data values. 12, 12, 24, 29, 29, and 36. And then the next thing you want to do is go ahead and just find the mean. X bar, remember, is the sample mean, which is the sum of x over little n, the sample size. So we're going to add all of these values up. Plus 12, plus 12, all the way down to 36, and we're going to divide by our sample size, which is 8. So we get the average is 22, which will go here. Now the next thing we want to do is go ahead and write down the formula for the sample variance and sample standard deviation. So the variance is going to be the sum of xi minus x bar squared divided by n minus 1. So we have to find this quantity here, xi minus x bar, and that's what we're going to do here. So we're going to take 22 minus 22 and get 0. 12 minus 22 gives us minus 10, and minus 10 here, minus 10 here. 24 minus 22 gives us 2. 29 minus 22 gives us 7. 29 minus 22 gives us 7. And 36 minus 22 gives us 14. So the next thing that we're going to do is just square all of these values. So 0 squared is 0, and 100. Minus 10 squared is 100. 100 here. 4. 49. 49. 196. Now, to get the numerator for our formula over here, it tells us to add up. So we're going to add up. Remember, this symbol here means add up xi minus x bar squared. So that's this last column over here, 0 plus 100 plus 100 plus 100 plus 4, 49, 49, 196. Total here gives us 598. And that's going to be our numerator. And then the denominator is little n, the sample size, which is 8. We have 8 data values, 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 1, we get 598 over 7. And this is the variance. Now remember, to find the standard deviation, we have to take the square root of the variance. So the mean is 22. The standard deviation is the square root of 598 over 7. And now we'll find the median and the mode. Now to find the median, we first have to sort the data. So I'm going to go ahead and sort the data. And then we've got 22, 24, 29, 29, and 36. So the median is going to be right in the middle here. Remember, we've got 8 values. When you have an even number of values, you have to take the average of the 2 center values. So the median is going to be the average of 22 and 24, which is 23, which is right in the center of 22 and 24. So even if you don't even really have to do the calculation here, you can just say, well, what's right in the middle of 22 and 24? Well, that's 23, so that's the median. And then the mode is the most frequently occurring data value. So which data value occurs more than any of the other data values? Well, we've got 312, so 12 is the mode. Okay, moving on to the next question. This question deals with finding the mean of a grouped data table. So remember here, we really don't know what the raw data set looks like. Okay, we just know that we have 2 values in between 1 to 4.9. We have 3 values. Remember, Fi here is the frequency. So we have 3 values in between 5 and 8.9. We have 2 values in between 9 and 12.9. We just don't know what the values are. So for group data, we assume that xi is the midpoint. And to find the midpoint, we're going to take the sum of consecutive lower class limits and divide by 2. So the midpoint of the first class is going to be 1 plus 5 divided by 2. So the midpoint of the first class, I'll denote this as x1 is equal to 1 plus 5 over 2, 6 over 2, or 3. And then at this point, the easiest way to get the next midpoint is to just add the class width, which is 4. So remember, the class width is the difference between consecutive lower class limits. So 5 minus 1, so the class width is 4. So 3 plus 4 is 7, and then 7 plus 4 is 11. And now we're going to get the last column over here, fi times xi. So 2 times 3 is 6, 3 times 7 is 21, 2 times 11 is 22. So now we'll write down the formula for the mean for group data, which is the sum of xi times fi divided by the sum of the frequency. So the numerator we're going to get from adding up this last column here, 6 plus 21 plus 22 gives us 49, and so that's the numerator. And then the denominator is the sum of the frequency. 2 plus 3 plus 2 gives us 7. So the mean for this grouped data table is 7. Now, the raw data set, remember we didn't know that in the beginning, but now we can actually produce the raw data set. So we've got 2 3s, we've got 3 7s, and we've got 2 11s. And if we were to add all these numbers up and then divide by 7, 1, 2, 3, 4, 5, 6, 7, we would actually get 49 the total over 7, which is kind of where the formula comes from. We do, instead of repeated addition, we do multiplication. Okay, now that we have the mean, let's go ahead and find the standard deviation for grouped data, which is the next question. And again, most of this is going to be the same, so the frequency is going to stay the same. We had a frequency of 2, frequency of 3, and a frequency of 2. The midpoints will be the same, 3, 7, and 11, but x bar is what we just calculated above. And so that's 7 all the way down. Now we compute xi minus x bar. So 3 minus 7 is minus 4. 7 minus 7 is 0. 11 minus 7 is positive 4. Now we'll go ahead and square these values. Minus 4 squared is 16. 0 squared is 0. And 4 squared is 16. Now we'll multiply. Xi minus x bar squared times fi. So 16 times 2 is 32. 0 times 3 is 0. 16 times 2 is 32. So let's go ahead and write our formula down here for the variance, which is the sum of xi minus x bar squared times fi divided by the sum of the frequency less 1. So the numerator here is going to come from adding up this last column here. 32 plus 0 plus 32, 64. And then the denominator is going to come from the sum of the frequency, which is 7. So 7 minus 1 gets 64 over 6. And this number is the variance. Now remember to take the square root of the variance, gives us the standard deviation. So the variance is 64 over 6, and the standard deviation is the square root of 64 over 6. Okay, next question. Which is better, a score of 80 on a test with a mean of 70 and a standard deviation of 5, or a score of 55 on a test with a mean of 40 and a standard deviation of 8? So we're going to break this up into we'll just call it test 1 and test 2. And we're going to use the z-score for comparison. So the z-score is x minus mu over sigma. So notice we have to have x, we have to have the mean, and we have to have sigma for test 1. And then x and the mean and sigma for test 2. So test 1 will let the score of 80 with a test with a mean of 70. This has a mean of 70 and the score x is 80 and the standard deviation is 5. And then test 2, score of 55 on a test with a mean of 40 and a standard deviation S or sigma of 8. So let's plug in and we'll see what we get for the z-score. X minus mu over sigma. So 80 minus the mean, standard deviation, get a z-score of 2, and then over here (55 minus 40 over 8) gives us a z-score of 1.875. And so who did relatively better? Well, that would be the person, the test 1 would be relatively better because this person here scored 2 standard deviations above the mean, and this person here scored 1.875 standard deviations above the mean. So again, the person who scores above the mean the greatest amount would have the better score. So we would say something like test 1 score of 80. Okay, next question. The governors of 3 states appoint a crime commission. Below is the breakdown of the commission. So we have 10 men, we have 21 women, and then we have 12 individuals from Florida, we have 9 individuals from Tennessee, and we have 10 individuals from Georgia. If the chairperson, so we have a total, so this column here, or this row, this last item here, is the total individuals that we can choose from. So the first question says, if the chairperson is randomly selected, find the probability of getting a woman. So we want to know, what is the probability of W? And so how many women do we have? We have 21 total women divided by the total number of men and women, which is 31. And so this is the probability that we're looking for here, 21 out of 31. Now, the next question deals with conditional probability. So let's read through and find out what they're asking. Find the probability that a randomly selected individual who is a Tennessean. So who is a Tennessean? That's kind of the given part, is a woman. So the way that we write that is, what is the probability that we pick a woman given the person is from Tennessee? So what we're going to do is we're going to restrict ourselves only to the individuals from Tennessee, which are the 9 individuals here. And then of these 9 individuals, how many of them are women? 6. 6 out of 9. So 6 out of 9. This is kind of called a reduced sample space because we go from a total of 31 individuals down to only the 9 individuals from Tennessee. So the question, the probability is 6 out of 9. Okay, next question. In the following probability distribution, the random variable x represents the number of activities at least one parent of a 6th to 8th grade student is involved in. Find the mean and standard deviation for the distribution. Okay, so this one essentially just boils down to finding the sum of x times p of x for the mean. So the mean is equal to the sum of x times p of x. And so that's what we're going to find first. So we're essentially just going to multiply 0 times 0.073. And that gives us 0. And then 1 times 0.117 gives us 0.117. And 2 times 258 gives us 0.516. And then 0.966 and 0.92. So the mean is just going to be the sum of these values. So 0 plus 0.117 plus 0.92. So we add these up and we get 2.519 activities. So on average, at least one parent of 6th to 8th grade student is involved in 2.5 activities. Now we'll move on to the standard deviation. So let's write down the formula for the variance first, which is the sum of x squared times p of x minus the mean mu of x squared. So that tells us we have to get this second column over here. So what we're going to do is we're going to square x and then multiply times p of x. So 0 squared is 0 times 0.073 gives us 0. Here we get 117. 2 squared is 4. 4 times 0.258 is 1.032. 3 squared is 9. 9 times 0.322 is 2.898. And then 4 squared is 16. 16 times 0.230 is 3.68. Okay, so let's get this first part here, and that's going to be the total of this last column. So 0 plus 0.117 plus 1.032 plus 3.68, and then we're going to subtract the mean squared. So 2.519 squared. So this is going to give us 1.38. And this number here is the variance. And again, to get the standard deviation, we want to take the square root of the variance. So the standard deviation is just going to be the square root of 1.38. So the mean is 2.519, and the standard deviation is the square root of 1.38. Okay, next question. The probability of selecting a working alarm clock is 95%, 0.95. What is the probability of selecting 5 working alarm clocks? So the idea here is that the event of selecting a working alarm clock should be independent of all other events. So that means if you select a working alarm clock and you get one that works, that does not change the probability that if you select another alarm clock that it's going to work or not work. So these are all independent events, and that's the idea here. Independent events. So let's let the probability of selecting a working alarm clock be W working alarm clock. And we want to know what's the probability that the first alarm clock is working and the second and the third and the fourth and the fifth. And so since they are all independent, we can write this as the probability that the first one is working times the probability the second is working times the probability the third is working, so on and so forth. And so this is 0.95 times 0.95 or 0.95 to the 5th power. And I'm kind of curious about this one. What is the actual probability here? So this is approximately equal to 77.37. So approximately 77% of the time, if we select 5 alarm clocks, then all 5 of them would be working 77% of the time. And so what that means is if we select one group, a group of 5, and then we select another group of 5, and then we select a third group of 5, and then we do that 100 times, so we essentially have 100 groups of 5, then how many of these 100 groups of 5 would we observe the case where all 5 of the alarm clocks that we've selected would be working? And that would be about 77 of the 100 groups. 77 of 100. we would see all 5 of the alarm clocks working. In the other groups, they would not have all 5 of the alarm clocks working.